investigating the operation of an 8-bit adder-subtractor circuit. In this configuration on the DECV tesseric board, we're only going to use 4 bits for X and 4 bits for Y to add and subtract together. That's because of the limitation of the switches on the board. So here we go. We're going to test a couple additions and a couple of subtractions. We're going to start with the additions first. Something simple, 1 plus 1. So we're going to add 1x and 1y, and we should have 2 indicated by the binary output, indicated by the LEDs. So 1 plus 1, and scrolling down, we're going to add 2 plus 1. So we're going to add 2 plus 1, 2 on the X, and 2 and 1 on the Y, 2 plus 1. So that should give us 3. And we have 3 on the LEDs, and we're going to continue adding. The next addition operation is going to be and if my computer would ever start to work right, I might be able to find 1 plus 1. Two plus 1, we did 3, and the next addition, 2 plus 2 is 4, so we're going to add 2 plus 2, set everything back to 0, 2 on the X, and 2 on the Y should give us 4, which it does, and 4 plus 4 we're going to do next. And 4 plus 4, 4 on the X, 4 on the Y, gives us a binary count of 8 as indicated by the LEDs. Scrolling down on the very slow computer, we're going to go into subtraction now to test the subtraction of the 8-bit adder circuit. So we're going to subtract 8 minus 1. Setting the X bits to 8. And we're going to, I forgot to mention, we got to push the subtract switch, which is the last switch on the bank there, into the one position indicated by the carry output bit coming on. And we're going to subtract 1 from 8. We have an 8 in the X side, and we're going to subtract 1 bit on the Y side, so that 8 should go to a 7, which it does, indicated by 1, 1, 1 for a 7 binary. Okay, that test passes. Now scrolling down on the ever so slow computer, we get the next test, which is 8 minus 2. So again, we have 8 set in the first bank, and we want to subtract 2. So 2 in the Y bank. That should give us 6, which it does. Okay. Scrolling down on the ever so slow computer, we have the next test, which is 8 minus 3. Okay, so again, we have 8 set up on first bank, and we're going to subtract 3 from 8. So 2, 3, 3 from 8 is 5, as indicated by the LEDs for the binary count of 5. So I believe that's it for the test. Oh, one more. Okay, on the ever so slow computer, we're going to subtract 8 minus 4. Again, we have 8 set up in the first bank already, so we're going to subtract 4 from that. Okay, 8 minus 4 should be equal 4, which it does. And I believe that's the final test. Scrolling down a little bit more. Yeah, that is the final test. 8 minus 4 equals 4. And that is going to do it for lab number 4, ECE102 at Colorado State University. This is Chris signing off. And just a quick pan to indicate that we completed the test.